Yeah, welcome to Electro Hive Research Institute of Technology. My name is Yakub Mohammed. Like I said in my previous video, I was going to show you how to configure the PWM board, the spwm board. This is the spwm board. As you can see, I've connected my display, which is my LCD interface. I did say this is not a conventional LCD interface. It's actually a serial bus where I've converted the serial to LCD. Then I did say that I added another hardware interface for my LEDs that I've not added yet on my programming code. Once I update that, I would do a separate video. The next connector I have is for the power switch, where the inverter can be switched on and switched off, just a pin connecting to ground. And something I wanted to show us too. Here I have two pins. The first two pins are for the debug. If I need to test, I will need to connect my debug. I will need to close my debug switch, so it allows me to test the board without shutting down, because we have low voltage shutdown, we have over voltage shutdown, we have high temperature shutdown. To avoid those shutdowns while I'm testing, I will just need to close my debug switch. Then my configuration switch, I did say that this board can be configured for different use. So depending on what I want to use it for, whether I'm using for a 1 kVA 12 volt, a 2 kVA 12 volt, I'll need to send those configuration parameters to it. And to do that, I would need to connect it to my computer system and send those parameters to it. So this is a new board that has not been configured before. So the first thing I want to do is power it by connecting to my computer. Okay, you can see on the LCD where all we have is Erit power loading. Please wait. The LCD is trying to get valid information or parameter from the control card. Once it gets that, our screen will change. We can hear a beep sound. The beep sound is saying there is a configuration error, meaning that the board is not properly configured, or the configuration data is missing. So let's connect to the system. Okay, what I have here is the serial to USB converter. My serial to USB converter allows me to connect the board to my computer system, where I can set my configuration parameters from. So going to my screen, I have a serial utility software. You can use any serial utility software. This is a Windows-based utility software. I'll need to connect to what port I have. It's on port 8. The baud rate is 115200. Data bit is 8 bit. Parity is none. Stop bit is 1. Flow control is none. Once you set those parameters, you can connect to it. Let me just close this. I'm not using a registered software, that's why I'm getting this. Okay. So I'll connect to it. Okay, from our screen, what we are getting is fatal error, invalid configuration parameter, and this is the parameter that is getting. That means these parameters are wrong. So the next thing I want to do is set the pin properly, so I can go to configuration mode. So I'll just pull this pin and close the configuration pin. Once that is done, I'll just reset. Okay. Alright, I'll just clear my screen and do the reset again so that we'll get the configuration information. Okay. From our observation, the noise has stopped because it's actually in configuration mode. So what we get on our screen here is configuration mode. So configuration mode means that I can now send my configuration parameter. Our configuration parameter that we need actually 21 bytes. The first byte being a star and the last byte being a hash. Let me just take, I've used one before. Okay. So the first byte is a star and the last byte is a hash. The first byte is actually a header and the last byte is a starter. Sorry, a starter and a header. Like I said, it requires 19 valid data. 21 because you're adding the starter and the header, so we need 19 valid data. In our GitHub account, I've explained what this data, each bit is saying. The first bit is for battery voltage. If I'm going to be doing a 12 volt battery or 12 volt system, I would put that value as 0. If it's a 24 volt system, that value will be 1. The next byte, which is showing 0, is the battery type. The battery type can either be AGM, float, tubular, as the case may be, and the values are from 0 to 3. The next byte is the charging current, which are 2 bytes. If I'm going to be charging with 10 amps, I would specify it to be 10. If I'm going to be charging with 60 amps, I'll specify with 60. For now, I'm only using 4 valid charging current, which are 5 amps, 10 amps, 15 amps, 20 amps, and of course I think I added 30. I don't know if I've tested that anyway, and 30 amps. The next 4 bytes is our battery capacity. Of course, you know our battery capacity ranges from, it's actually in milliamp hour, and it ranges from say 50 to whatever value you want to use. For this case, I'll be using a 400 amp hour capacity. The next 5 bytes is the power. The power can range from 750 watts to 10,000 watts, as the case may be. The next 3 bytes is the minimum voltage you want to generate. Let's say I want my inverter to range from 210 to 140. It means that my minimum voltage will hold 140 and the maximum voltage will hold the 210 I really want to hold. If I've gotten all these parameters correctly, I would send to my system. So let's just click the send button and see. Okay, from the device, we saw the LED blinks, meaning that it's getting valid parameter, valid data parameter, configuration parameter from the system. And on our screen, we saw the dot to indicate that is an ongoing process. Apparently, there's a function that is actually being executed. So once that is correctly done, if you get your valid parameter correctly, what you see on the screen will be what you have saved. From our screen, we are seeing maximum power is 1500 VA. The numbers of battery, 12-volt system. That's because the numbers of battery we have set from here is 0. 0 means 12 volt, 1 means 24 volt, as the case may be. Then the next parameter is the type of battery we are using, AGM. The battery capacity is 400 amp hour. The charging current is 60 amp. I did say for now, I've only tested for 4 or 5 constant charging current, which are 5 amps, 10 amps, 15 amps, 20 amps, and 30 amps. Then, of course, other parameters that we don't, that are constant, we don't set them for now, is the equalization voltage, the bulk voltage, the absorption voltage, the float voltage, the low battery voltage, the nominal battery voltage. Then the last 2 parameters are actually what are configurable, which is the 160, meaning that my inverter will get to 160 before it switches off, and the maximum volt that the inverter can get to is 210 volts. So let's say we were to change the power to, let's say, 750. I'll just go to the power section and change it from 1005 to 750. 750. Okay, let's send that and see what we get. Okay, so as you can see now, the power has changed from 1500 to what, 750 VA. Let's say we are going to be doing 200 amp hour battery. We'll go to our parameter setup and change that 4 to 2. Let's say we are changing the charging current to 10 amps. You can change the 6 to 1. Let's send and see. Okay, we've seen that the battery capacity has actually changed to 200 amps, 200 amp hour. The charging current has changed to 10 amps. Let's say we have to change the 750 back to 1800. I'll just go back to this and change it to 1800. 1800. Okay, let's say we are good with the charging current. And let's say the minimum voltage, we want it to stop at 180. I'll change that to 18. Let's say maximum, I don't want to go beyond 220. 220. I would save that. Okay, now we've got something. So your configuration parameter is invalid and was not saved. That's because we actually set a value. The minimum value cannot be 180. The minimum threshold for the inverter cannot be greater than 180 because that's the lower range of the high voltage, high threshold voltage. So what I can get maximum is 160. Let's try 170. I know 170 is not valid, so I expect to get an error, which we did. That is still an error. 170 is not a valid voltage for the minimum range. Let's say 150. Save. Okay, it took that. So like I said, it does not accept the minimum for the minimum voltage is between 110 to 160, and that for the maximum is between 180 to 240. Okay, let's say we are changing our 24 volt system, our 12 volt system to 24 volt system. So I'll take the first parameter as 1. I'll save this. Okay, so it means that our inverter has been configured to run at 1000 to run at 24 volt system at a power of 1800. The battery capacity actually 200 amp hour. The charging current is 10 amps, and we said the minimum AC voltage we want to generate is 150. Then the maximum we want to generate is what, 220. So like I said, I'm leaving this everything I'm doing on this project, I'm going to be uploading on our GitHub account. If you want to build the same project, you can go to our GitHub account and copy, and you can build it yourself. It's an open source. I still intend to make the board smaller. I'm looking for persons who could help me design using SMDs. As you can see from the board we are using a card which I'm not too comfortable with. It's because we do not have the technology to build a smaller PCB. That's why we're using the IP, and that's why our board is big. But like I said, I'm still looking for persons who I can partner with, who can help me design using SMD, so I can make the board smaller. Once again, I want to appreciate your effort in helping us. I want to thank you for taking your time to watch our video. If you have any comment, please drop it for us. We'll get back to you as soon as we can. Thank you very much.